Well, thank you very much for the invitation to speak this evening. So, as Roger said in his introduction, I'm going to talk about the mystery of mating. And certainly for me, when I first started keeping bees, I realized that mating with honeybees is completely different to any other concept that I'd come across before. So I have an agricultural background, and I'm perfectly used to putting a bull with a cow in a field and knowing who has mated and what the outcome will be. And so when I started keeping bees and realized that this is something completely different, I have little or no control over it, it really did make me realize just what an amazing feat it is. And you know, just what a marvel it is that it actually happens successfully the majority of times. So in this talk, I'm going to look at why we need mated queens, when it happens and where it happens, and then how we may be able to influence that. So, of course, we all know that mating in honeybees actually takes place on the wing. It doesn't take place in the hive. So this period of time when the queen actually has to leave her nest and go off and get mated makes her incredibly vulnerable. So again, this is another reason why it may not always be successful. There are plenty of birds out there that are also predating insects and feeding. So, you know, there's no reason why they wouldn't predate a honeybee by accident. So, you know, it really is a marvel that you end up with a mated queen. So, first of all, why do honeybees mate? Well, these new virgin queens that appear in our colonies for whatever reason, they need to mate before they become productive queens. And having a productive queen is really essential to how our colony operates. So they need a productive queen to enable brood rearing, and that leads on to having strong colonies and then a strong foraging force that then will go out and collect honey, nectar to produce the honey. So if they don't have a productive queen for any reason, if she doesn't get mated or she dies for any reason, this completely upsets the balance of the colony, and then the colony takes steps to do something about that, if it's at all possible. So they won't tolerate not having a productive queen within their colony. It is completely essential to their being. They won't just tolerate having an unmated queen that just hangs around and does nothing. It's of no use to them, absolutely, you know, no use. So they need to have this productive queen to enable the colony to go on and be a viable unit. So the worker bees and these new queens are produced from diploid eggs. And in order to get diploid eggs, mating is essential. And I'll come on to explain that in a bit more detail in a minute. So honeybees are part of the Hymenoptera order of insects. So they are part of the same order that ants and wasps also belong to. And they do things differently to mammals and indeed to many of the other insects. And they have what we call haplodiploid sex determination. So within this, the females are diploid. That means that they have two sets of chromosomes, and the males are haploid. They just have one set of chromosomes. And the easy way to remember this is the males have half the number of chromosomes, so half is haploid, and females have double the number of chromosomes, so di is 2. So during egg development within the honeybee, within the queen honeybee, within her ovaries, the egg cells undergo a series of divisions known as meiosis. So you need to now think back to your school biology days and when you learnt about meiosis and mitosis. So these cell divisions that take place during meiosis, they result in the egg cell becoming haploid. So you have a series of cell divisions that split that egg cell until it has half the number of chromosomes. Now, that's what happens in the female. In the male, it's a little bit different in that he undergoes incomplete meiosis. So because he only has half the number of chromosomes in the first place, he doesn't want to go through complete meiosis, otherwise he'd end up with half the number again. So he undergoes incomplete meiosis, or the gametes do, the sperm cells do. And then when fertilization takes place within the queen honeybee, then that's when these chromosomes then join back together and you end up with two sets again, if in the case of a worker honeybee. So this is kind of what that looks like diagrammatically. So on the left-hand side then, we have our diploid queen bee here. And as I mentioned, these meiotic divisions take place to produce her eggs. And so each egg then that she produces has half the number of chromosomes. If no fertilization takes place of those eggs, then that results in drones, which are haploid. Now, if you then switch to the right-hand side of the screen now, you'll see the male honeybee, the drone here, and he's haploid. This incomplete meiosis process takes place that results in his gametes, the sperm, also being haploid. And then if his sperm fertilizes eggs from a queen, these eggs also are haploid because of the meiotic divisions that have taken place. And this results in diploid workers. It could also, of course, result in another diploid queen if that colony chooses to produce a queen. So I hope that has quite simply explained how we end up with haploid and diploid males and females. As with many things, it is obviously a little bit more complicated than that, but let's just leave it at that simplistic view just for ease of describing it. So why might we have a virgin queen within our colony? Well, the most common reason that we will all have encountered is swarming. And swarming takes place usually throughout the summer months, early summer, and annoyingly also you often get it in the late summer as well. And that's where the colony is actively trying to reproduce. And so you end up with virgin queens being produced. Supersedure is another situation where the colony decides that it wants to replace the queen. I have a couple of colonies at the moment that are looking to supersede. And so that's another time when you'll have virgin queens that will need to get mated. Emergency queen replacement is another time when you're likely to have queens, and emergency queen replacement might occur for several different reasons. So that might be you accidentally destroyed the queen during an inspection, or she may have died of old age, or any other factor really. So the colony will then take steps to raise a new queen to replace her, and again you'll end up with a virgin queen that needs to get mated. And then of course there's organised queen rearing situations, such as the picture describes here, where there'll be a virgin queen within this apodea waiting to get mated. So that's why we have virgin queens, and there are several different time points throughout the summer season when these are likely to occur. So this is a queen, and you'll notice perhaps the most striking thing about the queen bee is her very large abdomen, and that's really what characterizes the queen. she is effectively an egg-laying machine. And her ovaries, she has very large ovaries contained within this abdomen, and that's pretty much all there is space for. She doesn't have the same sort of crop that the worker bees have for collecting honey, because for collecting nectar, because she doesn't need to go off and collect nectar in the same way that the worker bees. So her abdomen is primarily there to house the ovaries. She does have a sting as well, and obviously, you know, a gut, but that's very much, you know, sort of squashed in there around these ovaries. You'll notice as well on her rear legs, she doesn't have the long hairs and corbicula for collecting pollen, these sort of pollen baskets that on the hind leg that the worker bee has, that have very long hairs to help hold the pollen there. She doesn't collect pollen, so she doesn't have that in quite the same way either. You'll notice with this queen as well, I wasn't terribly accurate with my paint splodge, so that always shows up when you go into a high definition picture. So let's look at the queen then, internally. So this picture is taken from Dade's book, Anatomy and Dissection of the Honeybee. If you have the opportunity to look at this book, or indeed you may have a copy, it really is a fantastic book. And this shows a pictorial representation of what's inside the queen's ovary. So you'll see how it really is dominated by her ovaries. They actually look a bit like long strings of sausages. And what's happening within her ovaries is at the sort of top end, so to speak. This is where the egg cells are beginning to develop, and all these sort of they'll be surrounded by nurse cells that feed and help those egg cells to develop. And this is where these meiotic divisions are taking place to enable the development of these eggs. And as they gradually move down, they're developing and getting larger and larger, until at this end, you'll see they're fully formed eggs as they move into the oviducts and move down through to be passed out of the queen when she lays her eggs. This very perfect round structure here is the spermatheca, and this is where the sperm is stored. So after the queen is mated, she stores all of her sperm in this structure here. And she doesn't go out to have top-up matings later in life. So all of the sperm that she collects during those matings that take place on the maybe 2 or 3 mating flights that she takes early in life, she will be storing within this spermatheca. So really amazing that that sperm can last for several years, but also that she's got the capacity to hold enough sperm in here. And then you'll notice this little structure here that's called the valve fold. And this seems to be some sort of mechanism that enables the eggs to be fertilized as they pass down. So as the eggs pass down through the oviduct and then get passed out when they're laid into the cell, she'll be deciding whether or not she wants to release sperm with them as well to fertilize them if she's laying into worker cells or drone cells. And this mechanism here, the valve fold, actually helps enable that and will sometimes hold sperm back, or will enable it to be released into the oviduct to fertilize that egg. So, you know, really amazing structures here. And, you know, if you ever get the opportunity to actually dissect a queen, while it might feel a little bit barbaric, it really is worth having a look and, you know, seeing these structures for yourself. So that's what the queen looks like internally. And her sexual maturity takes approximately 1 week after she emerges from her cell. So we all know that development from egg to adult takes 16 days for a queen, and then we need to allow an additional week for her to reach her sexual maturity. And during this time, that's when her flight muscles will be developing and maturing, and her ovaries and spermatheca are also sort of finishing off this sort of maturation phase. And then as she develops and the days pass, the workers will become increasingly aggressive towards her because they recognize that she's becoming ready to go out and get mated. And so they'll be very keen to encourage her to go out because they need her to get mated. And so initially she'll probably just take a couple of orientation flights. She'll need to go outside of the nest and actually learn where her nest is in relation to the surrounding environment, and also crucially how to get back into that nest. So she'll be learning where the entrance to the hive is. And this will be taking place. You may be lucky enough to see these orientation flights taking place. Now, we also know that there are situations when multiple queen cells are in the hive within the brood nest, and that may be due to a swarming situation. Emergency queen cells are rarely produced just one. There tends to be quite a lot of them, and even supersedure cells, it's rarely just one. There tends to be a few of them. So the first virgin queen to emerge will actually seek out the other queens and will probably kill them within the other developing queen cells. And if several queen cells emerge at the same time, they will quite often fight to the death. And of course, in a swarming situation, you actually get a process whereby the worker bees will hold queens back within the cells and sort of they control when they're released. And that's when you get cast swarms and things, but we won't go into that now. So of course, the colony only needs one queen. We do, of course, encounter situations where there might be more than one queen in a colony at a time, and indeed more than one laying queen. I'm sure several of you will be aware of supersedure instances whereby you have two queens that seem to coexist. It's actually mother and daughter, and they seem to coexist quite happily, sometimes for quite long periods of time. A couple of years ago, I actually had 3 queens in one of my colonies. And of course, it does sort of leave you in a bit of a quandary because you don't know who's actually laying, whether they're both laying or whether one is laying and the other's just kind of in her retirement. So, you know, it does become a little bit difficult to know what to do. I mean, the best advice really is to just leave them alone, they'll sort it out. But with this colony that I had 3 queens in, they did actually then enter into a swarming situation. And so, of course, when I wanted to do my artificial swarm, it's like, okay, so do I leave all 3 queens together or do I split them? So I ended up splitting them all in the end, just to see if they were all laying, but they weren't. So that was quite interesting just to know that. So this is the drone then. So he also has very characteristic features, and I'm sorry that the focus on this picture isn't brilliant. It's actually quite hard to get the depth of focus right on this. So first of all, you'll notice that while his abdomen is relatively chunky, it's not particularly massive. It's kind of just in scale with the rest of his body, but the large part of his body is his thorax. So this bit here that the wings and legs are connected to, and it's very hairy and very large. And that's because it contains his flight muscles. And that's perhaps one of the most important parts of his anatomy, because to be able to mate with the queen, he needs to be able to fly fast and strongly. So that's why he has such large flight muscles. He also has very large compound eyes, which are slightly more on the front of his head than they are with the worker bees. and much larger as well. And that's because when he approaches the queen in the drone congregation area for mating, the sort of final honing in on her position is done by sight. So he needs to be able to see where he's going. And then his antennae are one segment longer than the worker bees, and they also have far more receptors on these antennae that are very sensitive to pheromones, and it's the queen's pheromone that he's trying to pick up when he's out seeking virgin queens. He has very shiny rear legs. He does no pollen collection, so he doesn't need any hair on these legs to help with pollen collecting at all, which is in complete contrast to the worker bee. And then, of course, his sex organs are contained within his abdomen here. So again, referring to Dade's pictorial representation of a drone, so if we look at this picture here on the right-hand side, now these little structures on the ends, these are actually the testes. Now, interestingly, in the drone, the development of the testes and the development of the sperm actually takes place when the drone larvae is developing. So in the larvae of the drone, the testes are really quite enormous compared to the rest of the larvae. Whereas now that the drone is actually matured and emerged from the cell, they're starting to shrivel. He doesn't continue producing sperm throughout his lifetime. He produces, all his sperm is already produced when he emerges, and he stores it then in this section here, and then this part here is what produces all the mucus that transports the sperm gets stored in the vas deferens, which is this part here off the testes, and then the mucus comes from this part here, ready to form part of the ejaculate when he mates. So this, these pictures here on the left, this is the rear end of the drone, and this is his reproductive organs that's been everted from his body, so that you can see how it kind of unfolds from within him. A bit like if you have a rubber glove that's turned inside out, and when you blow it the right way, to blow into it to get the fingers to you know, unfurl back the right way, that's a bit like how his reproductive organs unfurl during mating, and then the sperm is ejected with this mucus that forms the semen then. So, just thinking a bit about the drone's life cycle, I always think it's quite interesting to note that actually his life is almost, well, it's in two halves really. So there's the half before he emerges. So from the day the egg is laid to the day he emerges takes 24 days. We should all be quite familiar with that. And then interestingly, he doesn't live for a lot more than 24 days as a fully emerged adult. He can live for approximately 5 weeks, but what it all really depends on is whether he mates with a queen, because he dies in the act of mating. It's a very sacrificial event. And then if he doesn't mate with a queen, then once we get to sort of late August, you know, about now, it's probably happened in a lot of colonies because of the bad weather we've been having, certainly in this part of the world. The worker bees will actually evict the drones from the colony. So in his first week of life after he emerges, he stays within the brood nest. That's where it's warmest, and he's maturing and he's eating a lot. And so that he'll be able to get food quite easily within the brood nest. And then once he's finished maturing, and from, you know, sort of roughly a week old, he'll be taking cleansing flights on a fairly regular basis, and also orientation flights and just getting to know, his surroundings. And then from about 2 weeks of age onwards, he'll be starting to take mating flights. And then when he returns to the colony, he tends to camp out then on the outer edges of the brood nest. He's got good access to honeycombs there, so he can feed up, but he doesn't need the full warmth of the middle of the brood nest. And of course, we know as well that drones don't always return to their home nest. They could return to another colony within the same apiary, or indeed maybe in another apiary close by. So they tend to get accepted fairly readily into hives. The colonies are happy to have drones within their colony. It all adds to the sort of colony coherence. And so they will accept drones from other colonies. So at what stage of the queen and drone's lives does their mating take place? Well, as I've just described, that takes place once they've reached their sexual maturity. For the queen, this mating only takes place in the first few weeks of her life. So she may go out on maybe 2 or 3 mating flights, and she'll mate with up to approximately 20 drones. And then after that, she doesn't go out on any more mating flights. So you don't get circumstances where maybe a week later or 6 weeks later, she goes out and does more mating flights. That just doesn't happen. So what happens within those few days when she decides to go out on her mating flights, when she's approximately 2 to 3 weeks old, that's really what dictates her productivity then for the rest of her life. And so that's why we're so sort of interested in queen mating. And, you'll quite often hear people talk about how it's been a poor mating season, or we've got queens that have been poorly mated, and then we get a lot of supersedure around this time of year. And really, it's all in the lap of the gods, particularly for us as hobby beekeepers, who are not artificially inseminating our queens, or, sort of operating slightly more controlled mating operations. So that's why the weather is so important. And this year, for us in the west of Wales, we started off in May getting really excited. May, was hot, and it looked like it was going to be a bumper season. We all rushed out to start our queen rearing, and then by mid-June things went disastrously wrong with the weather. And to be honest, I thought the queen rearing that I was doing then through June and into July was just going to be a complete write-off. And I was amazed when queens were still getting mated. So it remains to be seen how successful those matings are. In many cases, I probably won't know until next year when I open up colonies in the spring and discover whether or not late supersedure took place, or indeed whether queens just haven't made it through the winter. They may, of course, come through the winter and then start laying okay, but fizzle out fairly quickly because they may not have enough sperm to actually, carry on productively. And that's when you get drone laying queens. So it's very difficult to actually quantify how successfully mated your queen has been, and you very often don't know until months or the following year how successful that mating has been. So it really is a difficult thing to monitor and understand. Now, when it comes to these flights that we need our queens and drones to take, it's quite interesting that the books all talk about temperatures that are ideally above 18 degrees centigrade. You need sunny conditions, and certainly for drones, they will fly pretty much throughout the afternoon. If it comes, beautifully warm earlier in the morning before lunch, they will fly earlier than this. But their sort of general time for going out searching for virgin queens is between 1 and 5 p.m. And each flight that he takes will last approximately 25 minutes, and that's governed by how much fuel he can carry. So, you know, effectively they're little aeroplanes, and there's only so much fuel they can carry. And so for them, the amount of fuel that they can take on to fuel their flight will enable them to fly for approximately 25 minutes. And then that dictates the distance that he's able to fly. Now, again, you know, being a beekeeper in West Wales is all I talk about is the weather. And when we read the books and hear that he needs temperatures above 18 degrees C to fly, you know, to go out on a mating flight, it just makes you wonder how on earth any mating takes place around here. But it does. So that tells you that my bees are adapted to be able to fly at lower temperatures than this. Because quite frankly, since the end of May, beginning of June, you can count the number of days above 18 degrees C on one hand. So, you know, they need to be able to fly at slightly less than ideal conditions. And you've probably heard a lot about drone congregation areas. They're these mythical areas that we know that drones congregate in, and they're effectively described as reliable meeting points. And there's a lot of myth and history steeped around these drone congregation areas. The most famous one being down at Selborne in the south of England, that was discovered, you know, many hundreds of years ago, and you know, still to this day, every year, drones congregate in this drone congregation area that's been identified there. And of course, drones aren't learning from each other where these areas are. So there must be something about these areas that attracts drones to them. And we don't really understand what that is at the moment. So, you know, it's always nice to have some unanswered questions. So the drones will fly up to approximately 5 miles to these DCAs. And as I mentioned, that really is based on their fuel intakes and how much they can fuel up by. So they do prefer to fly to much closer ones. So just to give you an example, if you assume a flight speed of 12 miles an hour, a DCA that's 1.2 miles away will be 12 minutes of flying time there and back, which leaves 13 minutes then for finding a mate. But if the DCA is only 0.6 of a kilometre away, then the flying time is just 6 minutes. And so he's got 19 minutes to find a mate. So you can see how for drones, it's actually within their favour not to fly too far. It enables them then to hang about longer in these drone congregation areas before they have to come back and rest and fuel up. And they will take several mating flights in one day if the conditions are suitable. So what makes a drone congregation area? Again, we don't really know, and there doesn't seem to be consistent patterns with all the drone congregation areas that have been identified. There are some that have been identified where there are obvious changes in gradient. So for example, where steep valley sides open out to flatter land. There are some that appear to have been identified along sort of navigational features. So, you know, like hedgerows where it opens out then into open land. And it could be more thermal conditions or magnetic fields. We really don't know. This is the valley just below where I live, and I actually live at 700 feet above sea level. And amazingly, I find that the bees in my garden actually do get mated usually quite well, fingers crossed, that I haven't just jinxed that. And so I live, you know, sort of at the the top round the corner here, just at the top. And so what I don't know is whether my queens are getting mated in a drone congregation area, maybe down in the valley below me, or whether there is a drone congregation area kind of above my head, or, you know, near to some other feature in the area. I just don't know that. But what I do know is that they do generally get mated quite well where I live. So 700 feet obviously isn't a barrier to them. And obviously the rain isn't either, fortunately. So within the drone congregation area, there's quite interesting behaviour in that the drones tend to gather before the queens arrive. So the drone flying times, as I mentioned, tend to be sort of 1 till 5. And then the queens tend to be flying for a shorter period of time in the middle of that time point. So sort of, you know, 1:30 to 3:30. I mean, these times obviously aren't exact. This is just the majority of data demonstrating this that's been identified. So once the drones gather in these drone congregation areas, they hang out there waiting for the queens to arrive. And as I've mentioned, their flying time on average is about 25 minutes. And so that allows for up to 6 visits per day. And they do tend to visit the same drone congregation areas. Some drones will patrol several DCAs if there are several within close proximity, and others will just favour one. So, you know, again, there's no sort of hard and fast rule there. But what has been demonstrated is that these DCAs may contain as many as 14,000 drones, representing up to 100 local colonies. Of course, that depends on the density of colonies in the area. But, you know, there have been far more found to be represented as well. I've seen some papers showing that over 200 different colonies are represented. So in terms of choosing which DCA he goes to, that's very much based on distance. It all comes back again to how much energy he's got on board to be able to fly. So he doesn't want to expend all that energy flying long distances. So he tends to stay relatively close to home. And he finds his mate, so he seeks out these queens by detecting her pheromones, and he's using his incredibly sensitive sense organs on the antennae to detect the queens as they come into range. And then as he then spots those queens, to actually be able to hone in and narrow in to actually mate with her, he then relies on sight for that. So the drone, the pheromones produced by the queen are very much sort of swirling around in the air. And so they'll alert the drones that there's a queen in the area, and they'll all follow then in hot pursuit of this queen. But he does then rely on his sight then to actually pick up where she is exactly and then follow. So as I mentioned before, the drones ideally want temperatures above 18 degrees centigrade to fly and go out on mating flights, whereas the queens are even more fussy and they want temperatures above 20 degrees centigrade. They go out on these orientation flights to start with, which tend to be relatively short. They want to obviously learn where the nest is so they know where to return. But it's very dangerous for them to be outside of the nest, so they don't leave for long. And it really is only as necessity rather than as a leisure activity. So her mating flights will last for 15 to 30 minutes. And as I mentioned, they're kind of within this window of when the drones are out flying. So the drones hedge their bets a bit and tend to go out a bit earlier and come home a bit later, whereas the queens are a bit more specific. They're looking for the warmest part of the day and they're much more focused and specific on what they're doing. And as I mentioned before, you know, we know that queens will also fly at temperatures lower than this. They have to, otherwise I would never ever get any queens mated. And like I say, you know, so far this year, the queens that I have reared, you know, appear to be okay. So we'll see what happens next spring. So within the drone congregation areas, the drones, as I mentioned, they're patrolling. They'll be flying around and they'll be waiting to detect the pheromone as the queens arrive. And then as soon as a queen comes into range, they'll pick up those pheromones very quickly, and then they'll be hotly pursuing her in what's referred to as a drone comet. So you'll notice I don't have pictures to illustrate this. I mean, it's not something I've ever seen. And people do go out and kind of mimic this situation with tethered queens on balloons so that they can try and pick up where drone congregation areas are. And so that's, you know, quite interesting to learn and see. Now, once these drones are pursuing her, her selection of which drones to mate with is purely based on fitness. So she wants the drones that are able to keep up with her, basically. That's the only criteria that she can base her selection on. She doesn't view them or choose them or ask them to do any tasks. She literally flies through as fast as she can, and the ones that can keep up with her are the ones that are in with a chance of mating with her. So the first drone then will move into position behind her, and then mating takes place on the wing. So again, you know, a really vulnerable position for both bees to be in, both the male and the female. They could easily be predated by swallows or other birds that feed on insects. So he'll move into position until his thorax touches her abdomen, and then he'll be gripping her abdomen using his front legs from the sides, and then his rear legs grasp the abdomen from below. And then he can place his abdomen so that the sting chamber which she has opened, her sting chamber, opens up as he approaches, and then he can curve his abdomen into place to be able to then insert his reproductive organs. So this diagram that's taken from Biology of the Honeybee by Mark Winston just illustrates it perfectly. And this is far beyond my drawing skills. So you can see the drone here has moved into position and is clasping the queen with his front legs, and his rear legs are then just holding underneath that abdomen, and he's curling his abdomen around so that he can insert his penis into her abdomen. Now, then it requires a lot of pressure on his part to force his penis to evert. So like I described before, where you have, if you blow into a rubber glove to get the fingers to blow out, it's pretty much the same process. And he uses his muscles to contract and force all his hemolymph forward to force this eversion to take place. And that causes him to lose pressure, you know, sort of lose blood pressure, so to speak then. And then he flips backwards and his reproductive organs are torn from his body, and he falls backwards then to the ground. So he now dies. He doesn't die instantly. He does get to lie on the ground and think about it for a while. But yeah, he will die now, unfortunately. But his deed is done, and he's passed on his genetic material to the next generation. And so then you have this little plug of mucus that's left behind after his reproductive organs then drop away. And that's what then gets referred to as the mating sign. So then, just to see this, again, this is taken from The Biology of the Honeybee by Mark Winston, and this just shows what's happening inside pictorially. So this is the queen's abdomen here, and this is the drone's abdomen here. So he's upside down. This is his endophallus here, and then the semen gets deposited and forced into the oviducts here. And it moves down the oviduct and then eventually gets stored in this spermatheca here. So this, may take a little while. She will actually mate with several drones on each flight. She may take 2 to 3 flights and mate with up to 20 drones. And this oviduct is quite elastic, so to speak, to actually enable all the sperm to be deposited in, and she holds all the sperm within this oviduct during this mating process, and then it gradually moves up and is permanently stored then in her spermatheca until she's ready to deposit some as she fertilizes eggs. So it's quite an amazing thing to think that this is happening, sort of 10 to 20 meters up in the air. And it just kind of, when we are waiting for a queen to get mated, we know that we've got a queen mated by looking out for seeing eggs being laid in the brood nest. And we often just spare little thought for what has actually taken place to enable those eggs then to be deposited. So, I always think it's quite a marvelous thing that all this goes on without us really being aware of it. Now, as I mentioned, this sperm transfer takes place due to the drone contracting his muscles so that it forces all of his hemolymph into the endophallus, which then unfolds into the queen's genital orifice. And as I mentioned, that pushes him backwards, and then as they're losing height then because of his weight, she contracts her sting chamber to assist that full eversion of the endophallus, and that also helps the sperm transfer up into the oviducts. And then he becomes paralyzed and loses grip and falls to the floor. So, it's a very quick process. Because they don't have much time because of his weight causing them to lose height as they're flying. They really don't have much time. So it is a very quick process. Now, we've mentioned a bit about the mating sign, and Roger mentioned in his introduction that he's never actually seen one. I haven't either, but beekeepers do report seeing virgin queens coming back from mating flights and actually still having this mating sign, which just looks like a little white blob of mucus at the end of her abdomen. And so each drone that she mates with leaves a mating sign, and then that has to get removed by the next drone before he can mate with her. So if she's mating with several drones as she's out on a mating flight, the next one has to actually physically be able to move it either to one side or completely away to enable him to be able to mate with her as well then. So it's not really understood what the function of the mating sign is. Some people have suggested maybe it just holds the drone in place when he's in this paralyzed form. Some people have suggested maybe it's a visual sign for the next drone who then comes along to mate. But it certainly is, a little bit of a mystery, and we don't really understand it. And quite often when the queen bee gets back to the brood nest, if she's still got one of these mating signs attached to her, then the other workers will actually clear it away and remove it. So I just want to spend a few minutes now just thinking about whether this whole process of mating is beyond our control. Certainly as hobby beekeepers, we tend not to think about it too much. We tend to just be extremely glad and grateful when a virgin queen has got mated and our colony is then able to continue in this productive manner. But for some of us, we might actually want to be able to take this a step further and actually have some form of control over what's happening, and indeed have control over what genetics and what traits that we have within our colonies. So it's much easier to be able to select traits in our queens, because that's the part of the process that we do have control over. So we can monitor the queens that we have and make notes about what their favourable traits are. It may be they have, you know, good disease resistance, they're very calm on the comb, they are non-aggressive, they seem to have good nectar gathering capabilities. And so those are sort of favourable traits that we might look for and actually choose then to breed from queens that possess those traits. But with the drones, we have a little bit less control. We may be lucky enough to have access to secluded mating apiaries, where we can actually then control what drones are in those apiaries. So we can choose colonies that possess all the traits that we like and put those colonies into the mating apiaries and allow those drones then to be the ones that mate with our queens. You can also, you know, just if you have colonies that you particularly like, just encourage them to build drone brood and basically flood the market with the drones that you want. But of course, if you've got hundreds of other colonies within a 10-mile radius of where you are, you know, there's going to be hundreds of thousands of drones all in the mix up in the sky from everyone else's colonies as well. So, you know, you really do have little control unless you have very secluded mating apiaries. So really the only way around it is artificial insemination. And at a hobby level, that's possibly outside of our scope. It does require specialist training and equipment, and, you know, possibly a professional setup, but that doesn't mean to say that it's impossible. And I do know of relatively small scale beekeepers who do artificial insemination because they want control over what they're producing. So, you know, it does feel like it's out of our control, because for the most part, we just rely on the queen going out and finding whatever drones she comes across. But there are some things we can do if we choose to go down that route. Now, there are, of course, also a couple of situations when it may go wrong. I've alluded to this already. The weather clearly is one of our biggest factors. And if mating conditions are not favourable, the queen may take shorter mating flights, which means she has less opportunity to mate with several drones. She may even not make it back from a mating flight if she gets caught out in heavy rain, thunderstorms or such like. So, you know, there are plenty of situations when mating doesn't quite work out. So if she fails to return from a mating flight, you'll end up with a situation where your colony becomes hopelessly queenless. So they're not able to fix that situation because they have no eggs or young larvae then to build new queen cells from. So that's obviously a little bit of a disaster and requires intervention from the beekeeper then. This picture here is an example of where the queen is actually becoming a drone layer. So you'll see some normal worker brood, but then dotted all around and amongst it are drone cells as well. So clearly her laying pattern is becoming erratic. She doesn't realise that she's laying unfertilized eggs, which suggests that the sperm quality or the amount of sperm is insufficient there, and so she's actually laying unfertilized eggs into worker cells. And this may be due to failed or incomplete mating, And of course, in these situations, her ovaries will still produce eggs. And so, you know, she'll carry on laying, and then it very quickly becomes obvious that all is not well. And then you may get supersedure, and supersedure may occur because you've got a failing queen, an aging queen, and maybe that queen had incomplete mating. And you tend to see supersedure around this time of year. And as I mentioned, I do have a couple of colonies that are now starting to supersede queens. So I'll just leave them do that, or I may even just combine those colonies and just you know, reduce the number of colonies that I have. And then of course, if you end up with queenless colonies that have no queen at all, once all the brood has emerged from those colonies, you run the risk then of having laying workers. And that's characterized by having multiple eggs laid around the side of the cells, because the worker abdomens can't reach right to the bottom. And, you know, that's a pretty hopeless situation to have as well. And if at all possible, you want to avoid having a situation of laying workers, just because it's not that easy to solve. So those are some of the scenarios that you'll find when it does all tend to go wrong. But for the most part, you know, this magical thing that happens up in the sky does usually work. And, you know, it's always very pleasing when, you know, a few weeks after a queen has emerged, you start seeing eggs within the colony. So just in summary then, you know, I've mentioned a few times how this really is an amazing event, and it happens despite all the odds being stacked against the queen. You know, she has to put herself in a very vulnerable position by leaving her brood nest. She has no protection from her workers when she's out on that flight. She really is on her own. She goes out, and, you know, the elements and other predators are out there. So, you know, it's amazing that she makes it back. And the whole process enables genetic diversity. It's really important that does happen. Genetic diversity is what, you know, keeps a species alive and thriving. The drones make this very sacrificial contribution, and I mentioned how that allows a very speedy transfer of sperm, because obviously she doesn't want to be out there too long. So the fact that he can transfer this sperm very quickly enables her to get back home as quickly as possible. So whenever you do find these eggs in your hive after you've been waiting for new queens to get mated, just remember the danger and sacrifice that's been made to get to that process. And hopefully you've all had successful queen matings this year, and you'll have fully productive colonies in the spring when things get going again. So thank you very much for listening, and I shall stop sharing my screen now, and we can join back with Roger and see if we've got any questions.
Thank you very much, Lynfa. Yes, we have. We've got quite a number. Some of them I'm going to have to discard because you did answer them later on. One that's been asked in a couple of ways is, does a queen have an entourage on her mating flight? And if so, how many bees?
Yes, she does to a certain extent. So when she leaves the hive, quite often people will actually witness this, and they'll see a whole entourage of bees actually coming out of the hive with her. But once she's sort of up in the air and going out on her mating flight, they tend not to go with her then. So it tends to be more around the nest site rather than on the whole flight. You know, once she's up in the drone congregation areas, she's just being pursued by drones then. So there are no workers then with her. But as she leaves and returns, then the workers will become very excited and certainly sort of assist her on her departure from the hive. And then as she comes back in, they'll be then fanning around the entrance to release this Nasanov pheromone to attract her back to the correct entrance into the hive.
Yeah, you've actually I know this is your talk, but you slightly hit upon something else, because I'm fairly convinced that quite a lot of queens are lost because they're going out to get mated from an apiary, and then beekeepers are handing other hives, perhaps bigger, when they're out. And then when she comes back, she might get confused by bees fanning at the entrance of the bigger hive.
Yeah, and I think quite often happens is in the summer where we'll be inspecting bees when conditions are most favourable for inspecting bees. And of course, if you're in an apiary where you've got queens that want to go out and get mated, you're probably going to conflict time-wise with when they're out on mating flights. So you do need to be really careful of this. If you know you've got queens that need to get mated, try and avoid being in your apiary at the same time, because you don't want to interfere with when queens are leaving and returning from mating flights. So yeah, I think you're quite right that probably is quite a common problem.
You mentioned drone congregation areas, which has sort of led on to another question. Do you know whether drones would mate with a queen from the same hive?
So it is possible, but obviously from a genetic evolutionary point of view, that's not ideal. So drones tend to not fly very far to a DCA. They tend to sort of stick within, sort of a mile or so of their nest site, whereas queens will tend to go a little bit further. They will actively try and fly away from their nest site. So that's how, as a species, they try and ensure that they're not mating with their own drones from their own colony, is by favouring different distances. So queens tend to go further than the drones.
And do you believe in apiary vicinity mating? Because that could be one area where perhaps it could happen.
Yeah, and I'm sure it does happen, particularly in situations where we have unfavourable weather. It is quite likely that, they're literally going to go out and just sort of do what they can as quickly as they can. So yeah, I'm sure it does happen, but like I say, from an evolutionary point of view, that's not what they want to do. They want to be in different areas to ensure this genetic diversity.
This next question isn't really relative to what you've been speaking about, but I think it's quite important. With formic acid reducing fertility of drone semen, should we be avoiding max during presumably the use of max during the spring mating season?
Wow, now that is an interesting one. Now
lecture, isn't it?
Yeah, I don't have any knowledge on whether it's actually, what the situation is with formic acid reducing drone fertility. But certainly if there is evidence out there that is occurring, then yeah, you would be, quite right to avoid using it in the early part of the season. So it's the early part of the season where the majority of your drones that are actually going to provide some sort of service to your queens are being produced. They're produced much earlier than the queens. So, that early part of the season is often what conflicts with when we might be seeing Varroa in our hives coming out of the winter, and we want to use a product that we can use quickly, because we might be thinking about honey supers, and so of course max tends to be the product of choice. But if there is evidence that it is causing problems with drone fertility, then yeah, I would certainly be avoiding it.
One interesting question, what volume of sperm can be stored by the queen? I assume they mean in the spermatheca.
Yeah, I don't know actually, and I'm sure a good place to look would be in Koeniger and Koeniger's book, where they talk about the mating process. So I don't know off the top of my head what the volume is, but yeah, it's pretty small.
This really is relevant to different parts of the country, but you mentioned late supersedure. What is the latest in the year this can be successful? It's obviously going to vary depending on the part of the country, isn't it?
It is going to vary, and of course, what ultimately decides on whether late supersedure will be successful or not is whether you've still got drones available for mating. And at the moment, I do still have drones in my colonies, but not many. They are being evicted now. So, you know, any supersedure that's happening now, I'll be keeping a close eye on. And like I say, you know, I may just look to combine those with viable colonies rather than risk running them into the winter with no queens.
There is a theory that the different honeybee subspecies are mated at different altitudes and that in a mixed population, this reduces hybridization. Do you know anything about this?
I don't know a huge amount about that, but I believe that is correct. And it makes sense, really. And I think that's probably why we see successful matings still taking place with our colonies. You know, like I've referred to several times how rubbish the weather has been this summer. And yet, you know, I'm still having successful queen matings. So I suspect that I have, while I don't have pure native bees, I suspect that I do have a significant proportion of Apis mellifera mellifera in my bees, and maybe that is predisposing them to the ability to be able to mate in, you know, non-ideal conditions. So yeah, absolutely, I'm sure that is the case.
And this is the old chestnut, which I was hoping to address next week, but you could do it for me. Does the sperm completely mix when stored in the spermatheca, or does it come in batches? That is, can a colony become aggressive due to the sperm?
Now, this is an interesting point because we've all had it happen where we've had a lovely colony and it's turned aggressive. And so, you know, the assumption then is that the genetics then has changed within the colony, and that surely must be down to the drone's contribution. So the science is telling us that mixing of sperm does take place. And Koeniger and Koeniger's book is an excellent reference to read up more. It's the book's actually, I've got it here. It's called Mating Biology of Honeybees, if anyone wants to have a look. And they describe in this book how they've actually, you know, dissected out queens that have become mated, and they've analysed the semen, and it is, you know, fairly well mixed. And mixing tends to take place better in natural matings than artificial insemination because of the elasticity of the oviducts, enabling sperm from multiple matings to be collected, and then it kind of gets, you know, churned around as it then migrates up into the spermatheca. So in theory, it should be completely random, but you know, we've all experienced this in practice where we do get changes in the workers. So yeah, the jury's still out on that one, I think. You can address it in full next week, Roger.
This is another interesting one. Regularly, usually in July and August in mid-afternoon, in brackets 4 p.m, question mark, my bee buddy has invasions of large numbers of drones into her apiary, and they enter the hives and appear to eat the stores. There has been a suggestion that their apiary is near a DCA and the drones are feeding before going back home.
Wow, well, I mean, that's quite an observation to make for a start, isn't it? You know, if that is happening, then yeah, I can only surmise that you've got a DCA close by. But, you know, you need to be also, it'd be interesting to know whether you experience high varroa counts after events like that. You know, it's quite common for drones to be carrying varroa mites. And so if you're getting mass invasions, I wonder if it's affecting the varroa levels within your colonies as well.
Well, I would guess it's actually drones taking flying lessons, because they do in mid-afternoon, and I think Absolutely. It's misinterpretation.
Yeah, could well be.
Yeah, I
Yeah.
think so. This is an interesting one. If queens are artificially inseminated, do they still instinctively go on a mating flight, or do they somehow realise that this is it for now and it's not necessary?
Oh, good question. I don't know the answer to that, but I suspect that they probably don't instinctively go on a mating flight. But I don't know. That would be an interesting one to find out. I'll have to do some reading.
This is actually another quite interesting one too. Are there upper temperatures above which they don't fly? The hot weather seemed to delay a virgin queen in early August. Not a big sample though.
I suspect that they wouldn't want to fly if we have really extreme temperatures. Not something I ever need to worry about, but it is possible that, when we see temperatures consistently above 30 degrees C, that may cause a problem, just like it causes, you don't see as much foraging taking place in extreme temperatures either. But in the UK, I think it's probably quite a rare event to have temperatures that will stop mating flights.
Mm. This one isn't particularly relevant to what you've been saying, but it's still quite interesting, bearing in mind we've got the National Bee Improvement Programme coming up. How do imported queens cope with Welsh weather?
Yeah, well, they don't, basically. So we would always advocate having local stock, particularly when you keep your bees in slightly more extreme locations. So rainfall where I live is high, really high. And so, there's no point me having an Italian queen, because they may well raise big colonies and have very strong foraging forces, but they'll be restricted as to how many days they can fly to collect nectar. And then when they're all camped out in the hive, they're just eating any stores that they've collected anyway. So it really just isn't worth us importing bees like that to use in our colonies. We're far better off using local stock.
Right. Okay, thank you. This question is about 5 questions in here, but I'll start with one of them. I have often seen queens moving around with eggs sticking out of the abdomen, and I have been wondering if this is, if this is the time that the bees take the egg away and place in the queen cell. So really, they're sort of asking whether the queen actually lays in the queen cell or the bees do. And this is another one for you.
So I've also seen this whereby you're doing an inspection and you may see a queen with an egg, sort of semi-emerging from her rear end. And I'm pretty sure what's happened in this situation is that you've just disturbed her. As you've opened up the hive, she may well have been laying in a cell and you've disturbed her, and so she's not completed that laying. The queen does lay into queen cells when queen cells are being produced, but we also know that workers can move eggs because we've all seen eggs occasionally being deposited up into the supers just above the brood nest. So we know that eggs do get moved, but generally the queen lays into the queen cells.
This is one that you might have to go back to your program for. Did I get confused? It looked like the speaker's earlier slide suggested fertilized eggs produce male bees and unfertilized eggs produce females. I always thought it was the other way around.
It is the other way around. Now I'm worried that my presentation...
Actually, you changed that slide today, didn't you, I think?
So what I've got, hang on, if I just make this a bit bigger.
I'm sorry, folks, I'm keeping this going in case there is a genuine mistake and people get the wrong idea.
So The queen bee is diploid, and during meiosis, she ends up with haploid eggs. And then if those eggs aren't fertilized, she produces drones. And then again, using that diploid queen, meiosis takes place to produce haploid eggs. So that's perfectly normal. And then you have sperm from the males, which is also haploid. And then when those fuse during fertilization, you get diploid workers. Is that all looks correct to me? Does that look correct? Yeah.
Yep.
So yeah, hopefully that's clear. So yeah, you're quite correct in that you know, the worker bees are diploid, as are the queens, and the males are haploid. They have half the number of chromosomes.
Okay. I think we'll take this as the last question. I think you touched on it, but didn't explain it fully. How does the queen decide whether to lay a drone or a worker egg?
So what we think happens here, and again, this is one of these areas that's, you know, not completely clear, but it appears that she uses her front legs and her antennae to actually inspect the size of the cell, and that dictates then whether she uses a fertilized egg or an unfertilized one. So she measures the size of the cell, and the larger drone cells, she doesn't then deposit sperm as well. So it's just a unfertilized egg then deposited into the cell.
Okay, I think we're close it there. You've had a fair grilling for 20 minutes. Thank you very much indeed. Thanks very much, Lynfa, for the lecture.